Sanitas, and that's my pleasure to host today's three valued speakers for a fascinating discussion on how digital technologies could help manufacturing to become more sustainable and what also can be gained from this transformation. But first and foremost, just a few tips. First of all, you have to know that this webinar is recorded. To allow us to share it with the whole Lux Innovation community through our YouTube channel. You'll have on the right of your screen a dedicated chat tab. So here it's really to say hello, to present yourself to the others and things like that. For all the questions that you could have during the webinar, please ask them in the question tab. So it will be easier for me not to miss any question that you could have for our speakers. Then you have an interactivity poll tab, where some polls will be proposed during the webinar. So technology is the answer, but what was the question actually? So a survey by Manufacturing Leadership Council revealed that 60% of manufacturing executives in 2022 considered sustainability essential for future competitiveness. That's a significant increase from 40% in 2021. According to the same survey, manufacturers primarily concentrate on enhancing energy efficiency and reducing consumption alongside transitioning to renewable energy sources. These initiatives are fundamentally connected to achieving net zero emission targets. And this is where technology comes into play. The World Economic Forum has identified that by implementing digital twins can save up to 30% of energy in the manufacturing process. And this has been demonstrated, for example, by LG in one of its factories in Korea. But without further ado, let's dive into the topic with our first speaker. Let's welcome Sébastien Thomas. Sébastien is an electromechanical engineer with a PhD in environmental sciences and management from the University of Liège, specialized in energy and environmental design for construction and renovation. As head of the energy management department at Énergie Agence, he leads a team in energy monitoring, data analysis, and efficiency improvement. Sébastien, the floor is yours.
Thank you, Nicolas. Thank you, and thank you also for the invitation to this seminar. I just go to the first slide of my presentation. I will give a few words about energy data as a sustainability lever today. I will start with a short presentation of the company where I work, Énergie Agence. Maybe some of you knows really well Énergie Agence, just a summary of what we do. We are an engineering company which is dealing with services in energy and energy management. We are doing audits, we are doing decarbonation studies, we are doing also carbon footprints, we are involved in Enoprime, and so many things about energy. Decarbonation is a hot topic today. We hear about decarbonation nearly at each week in the news and so on. So there was a study in 2022 about industry and how to decarbonate. And this study shows there are many ways to decarbonate, but energy efficiency is quite important. We have 24%. An estimation of contribution to the decarbonization is 24% for energy efficiency. and that's what is the first topic when we speak about energy data. It's energy efficiency. I lead the department named Energy Management, but what is energy management? In fact, we have a definition. It's the process of monitoring, controlling, and optimizing energy consumption in a company or organization. It's a systematic strategy for maximizing energy efficiency and reducing energy-related expenses. It involves implementing policies, acting on equipment, and analyzing energy data. So that was for the definition. But when we speak about energy management, we have some main components. First one is about the data collection. We have to collect data to have reliable real-time data to make good analysis. It's the second component. And we have to act afterwards. It's not only analyzing data, but doing something for optimizing and afterwards evaluation of the benefits. Based on our experience, we have developed a methodology to show how energy management can help for decarbonation. The methodology is following. We have first to assess the needs, to find the most energy consuming parts. So where are the most energy consumer? Not measure everything, but measure what is important to measure. We can deploy and improve metering infrastructure. Afterwards, we have analysis. And what's important in data analysis is also alarms management, which is at least as important as data analysis, is to have alarms and to react quickly when we have something which is not correct. And after data analysis, we have 3 points, three levels for decarbonation. We have optimization of energy needs, to avoid peaks, to shave peaks, and to check also what are the network input and output, the energy network input and output. We can forecast energy consumption and generation, because many industries have now electricity production with photovoltaics mainly. And also we can propose, after analyzing data, we can propose mix of solution to decarbonate, not only shifting from gas to hydrogen in the future, but also to deal with storage, electricity storage, and thermal storage also. That was the methodology. Now I can just show a few pictures of what we practically do in the industrial sector. We deploy some measurement devices. We have electrical measurement. We have also flow meters that are non-intrusive measurement, because we don't want to cut pipes, to cut hot water or steam pipe to measure. So we have implemented some measurements. We have also another picture. It's a way to measure also, and I will come afterwards to that, to measure also for your most energy intensive machine, to measure the cycle, how when we have consumption, when the machine is on, standby, off, and so on. We can deploy this kind of data, of measurement, and grab some data about that. And also we can improve existing infrastructure. When you have counters, we should not install more and more counters. We can connect on existing counters. And here are some examples about smarty counters, about gas counter, and about your electricity measurement you have in your not going into details into the infrastructure, but measuring infrastructure, energy measuring infrastructure is quite complex, and it's not so easy to implement. So I will just give some points of attention to not forget when we are deploying an energy metering infrastructure. First, we speak about energy, but energy is not sufficient. We need other data. If you want to improve your process, you have to have also production data and so on. The interoperability of system is very important to avoid installing counters and counters, to have some existing infrastructure that can communicate with other infrastructure. And what's also important from our side is not only measuring electricity, because it's easy to measure electricity, but what is important is to cope with different kind of measurement, to be sure what are the energy vectors, how do we use them. So steam can be interesting, compressed air, water, and so on. And finally, another point of attention, which is something which it's a belief in the industry. At some point, it's data analysis tool is different from a supervision tool. When you have a supervision tool, you have generally mainly not any capabilities of analyzing. So it's not the same. It is not the same thing. We must pay attention to that. And still some examples of data analysis. It's for photovoltaics, as we have some measurement, and we can compare with the solar radiation. So we can compute indexes to know if your solar collector field is efficient or not, and we can follow up any discrepancy between what is expected and what is really produced. It's an example. We have also other example of dashboarding, which is important to see in real time what you are consuming, what are your energy use in your company or in your manufacturing plant. It's something which seems to be important. And also we have some graphical tools. I will not go too much into details, but we have some practical graphical tool to show and to find out where are the energy efficiency, where are the energy reduction potential, in fact. So it's the tools we use for analyzing, in fact. Here it's another example for ventilation. It's not, as I said, it's not only measuring energy, it's measuring also temperature and so on, to be sure we have the most energy efficient equipment. Here, ventilation, for example. And I come to the conclusion about energy management and what is the importance of measuring energy. We have seen energy efficiency is key for decarbonation, and for doing energy efficiency, we must firstly collect data, and we must do analysis, in fact. We summarize sometimes energy management as only artificial intelligence, as only sensors, as only data, as only web application. But in fact, there are many disciplines, in fact, and so it's important to cope with all these disciplines when we are speaking about energy management. Our experience is in around 25 sites that are completely monitored. We have every time we have quick wins, in fact, and we have large quick wins because generally the people they don't know exactly what are their energy use, and so operation schedules and And pumps operation, it's something which is easy to change and to make large energy savings. And another conclusion about for this speech is the blindness of any company about energy use is a clear menace for your future operating cost, for evaluating the future operating costs. And also we have some legal requirements now, and I think in the future it will be mandatory to have precise view of what we are using as energy. Finally, what we propose at Energy Agence, we propose our expertise in this field, in this energy management field, to achieve your energy efficiency goals. And to conclude, to finish the presentation, our added values in our companies. We have experience in measuring infrastructure. We have a pool of auditors that evaluate savings and implement them, which is also important. And we know also quite well the funding programs to decrease your return on investment period. So that's all from me, from my side. So thank you. I let the floor to Nicolas.
Thank you very much, Sébastien. And just a kind reminder to our audience, don't hesitate to ask your questions, to put some comments or any idea that you could have regarding the presentation that are delivered today. And we'll manage all these questions and comment at the end of the session. We take 5-10 minutes to have an open discussion with all our speakers. So now let's give the floor to Stephen Benians. Stephen is a climate action expert who helps firms achieve credible initiatives and long-term value. At SystemCert, he advises on reducing value chain impacts and ensuring offsetting integrity, leveraging his skills in communication, policy engagement, and business development. Stephen, we hear from you.
Thank you very much. So it's a real pleasure to be here. Thank you very much, Nicolas. And this is a really important topic in a really important moment. And it's really interesting as well to hear from Sébastien just now, because what I will be focusing on today is the role of manufacturing companies, such as he's been presenting, who are reducing their emissions and increasing their efficiency, but looking at their role within the wider value chain, which collectively has high emissions. Before going into that, so SustainCert, we are I would put ourselves in the category of tech for green. We are a verification and auditing body verifying that climate impacts and climate claims are real. And today I wanted to go over a little bit of the background for the wider emissions reductions challenge that the world has, the specific challenge for corporations, and the solution that we have developed for the very complex scene that is value chains, wherein manufacturing might be just one part, but everyone is impacted by that. So in terms of the background, as we know, there is a mass extinction underway. We can call it that. And the world must align with the Paris targets. And as you can see as well from this transition pathway, we do need collective action to get there. It will take a lot longer and will be a lot more costly to society with low cooperation. Therefore, corporations are committing to science-based targets. Science-based means those which, once they all align as companies, do actually reach the planetary target of limiting global warming to 1.5 degrees. And these are ambitious targets, and many committing, as you see on the bottom right here as well, to net zero targets. I won't go into details of exactly what that means. But the problem is acute when it comes to seeing firms and your own emissions in the context of a value chain. Now, I won't go into the details of greenhouse gas accounting, but just know that your own emissions in your own factory is what you call scope 1 here in the middle, but everyone that you sell to downstream, they need to declare their own emissions in terms of what is called scope 3. In other words, all of the emissions, the embodied emissions of the products and services that they themselves purchase, maybe from an energy intensive factory, for example, manufacturing the goods. And that's called scope 3. So you have to declare your emissions about the products and goods that you're buying, or indeed that you might be selling as a manufacturing company. Scope 1 and scope 3. So we're looking really at the complexity of the scope 3. The entire value chain is another way of talking about scope 3. And most firms' emissions are in scope 3 here. Possibly a slightly extreme case here, but it's a real one, taken off the name. By far and away, most emissions are in the purchased goods and services category, and that might well be, therefore, the energy intensive processes of a manufacturing firm from whom you're purchasing your key goods and services. The problem is that it's really hard to reduce those scope 3 emissions. You are sourcing from a factory. How do you get them to reduce their emissions? Particularly because you don't always actually know the precise factory that you might be sourcing from. This is particularly the case, for example, when it comes to the apparel industry, certainly agri-food, and also quite often in the manufacturing. Why is this? Well, you don't always know the suppliers or the chain of custody of the goods. Often there's unreliable or low quality data about the emissions from the facility that you're sourcing from, globally, I mean. And therefore you need a whole value chain approach to incentivize co-investment, partner with those high emission sources in order to reduce those for the benefit of both of you and the whole value chain. And so really the challenge is, how do you take data from an intervention in a mid-product manufacturer, an intervention to reduce the emissions, that is, how do you take data from that kind of intervention and actually apply it to others downstream so that they can claim those reduced emissions? It's not always so simple because, like I said, supply chains are dynamic. You don't know year to year who exactly you're going to be sourcing from. And so we have developed a solution called the Vivid platform, which manages from A to Z the verification of the real impacts that have happened. Here on the left, the first factor of verification, if you like. A real reduction has happened, thanks maybe to some of those initiatives that we heard about just now from Sebastian. And then the second factor is, how on earth do you model how those impacts are applied downstream, and who can actually claim those downstream, not just the immediate sourcer from that factory, but right down to the consumer. And so the Vivid platform, it's called Vivid, manages this from A to Z. And what do we mean by a intervention? Well, on the top, you have business as usual, with this little baseline data, this particular process. And once you've implemented a reductions project, you reduce your emissions here, as you can see in that red box. And those reductions will carry out right down the whole supply chain. But it's taking that data and applying it to the others that's key. As we can see here, we have an energy efficiency reduction project happening. Actually, this is a real project that happened, replacing coal-fired boilers with biomass ones in a facility. And there was ultimately a reduction of 14.8% of the final footprint. How do we manage the application of this data, the attribution of these reductions to all of those downstream, right down to the consumers, so that they too can claim this type of reduction data? So the key to this is being able to take those that reduction data that we've just seen in the previous slides and unitize them into what we've called impact units, so that once those reductions have been modeled by the Vivid platform that we have, right across all of the impact layers, the supply chain tiers, if you like, of the whole value chain, those impacts will be available for any firm downstream who've ultimately sourced from that facility that has made the reductions project. And the reductions are unitized in impact units, tons of CO2 reduced, basically, real primary data about the emissions that took place upstream, but to what extent they form part of your footprint downstream. And of course, as you go downstream, you're going to be adding emissions from what you're doing in your particular part of the value chain, but there will always be that slice of your emissions that is now lower because of that reduction that happened upstream. So this is a bit of Sebastian said as well, this is about the reduction of your overall footprint and making sure that you're credibly claiming and integrating into your own footprint or your own greenhouse gas inventory that slice that has been reduced thanks to that project in the facility. And so the impact units that unitize these reductions look a bit like this and gives you all the information about where that facility was, how much was actually impacted, the amount of materials that came out of that facility thanks to that reduction, and the year, for example, of that intervention, so that it can be claimed into the year of your greenhouse gas inventory report. Here's a little example actually from the agricultural domain for soybeans, but this could equally be for high-tech materials in the apparel industry or whatever. So it gives you all the information that you need to be able to track the amount of impacted goods, the amount of reductions that happened, and also the tracking of the ownership of these particular claims. What's really important here and what this system does is making sure that there is no double counting of reductions, so that everything that was impacted by that facility and only that amount can be claimed at a lower emissions factor. And so we really track this down for credibility of claiming, so that there are guardrails to make sure that what you claim is really what was impacted by that intervention. And so the whole platform that we have manages this, and it gives not just the firm who implements the intervention, but all those throughout the value chain who for some reason are unable to reduce their own emissions, because most of their emissions are in the scope 3. They need to be able to see the emissions, the impact units that are available to them, so that they can click on the particular commodity that has a high emissions for them in the scope 3 and be able to claim that and reduce it. And so this is overall what the Vivid platform looks like. You have a portfolio, and when you go into your portfolio, you'll be able to see all of the products that you typically source and all of the emissions that are associated with them. And you want to go on to the tile, if you like, that represents the particular good that you're sourcing that is a source of high emissions. And you will click on one of those tiles because they'll show you the emissions reductions that you'll be able to integrate into your inventory if you acquire that particular good from that particular area, from that particular intervention. So if you were to click on one of these tiles, you'll see something like this. All of the details of the emissions factors that are lower compared to what they were before, or from suppliers who have high emissions. And now you're seeing all of the emissions factors that are lower from the particular factory that's implemented that intervention. And you can request this impact unit, this amount of reduced emissions, to integrate into your inventory. So you would click on this tile, ask for it, the specific amount of good that you are sourcing from them. You can dial that up or down for the amount that you're sourcing from them. And then the person who owns that impact unit, the factory who has implemented that intervention, in other words, can transfer it downstream to their customer, or to the customer maybe whom they don't have direct traceability with, but who is nonetheless overall within the supply chain. And they can supply them that particular impact unit for that particular good. They can do this as part of a collaboration. They can sell also this to monetize and get a return on investment on that intervention that they had to reduce emissions in their factory. And so here we have an instance of transferring that impact unit to a downstream customer. And then that downstream customer will be able to see all of the details in more specificity about that reduction that they have. And here they will see basically their carbon footprint of this new good that they are sourcing. And that is the data that they can integrate into their greenhouse gas inventory that will consequently be lower and will allow them to meet their science-based targets year on year. And so therefore this overall is a solution whereby companies can not just, as you see here on the left, implement an intervention to reduce the facility emissions, but a way to collectively, as a value chain, model and claim those impacts credibly year on year to reduce your emissions and meet your value chain and science-based targets that you have as a company. So that is the overall presentation of this vivid platform that we have for credible claiming of value chain emissions at scale. Thank you.
Thank you, Stephen. That's very, very interesting. That's very, very dense, I would say, and we could certainly have hours discussing about that. But we'll come back to you in a moment, right after our last speaker of the day, Fabrice Hansen. Fabrice is an Industry 4.0 expert specializing in digitization, IoT, and automation. Sorry, my slide is not updated. Yeah, that's this one. As the CEO of Industream, he leverages his expertise in process control and optimization to drive innovation. Throughout his career, Fabrice has held key positions, including Vice President of Digital Transformation at Paul Wurth. There, he set out to improve the efficiency and the technology supplier to the global steel industry. Fabrice, we are listening to you.
It's a pleasure to be invited to this talk, and I hope I would say I will show you some concrete use case. So the idea is to show how this, I would say, digitalization and path to the decarbonization is also applicable for small and medium industries, not only for big companies, and how we can go step by step, how we can create concrete use cases, and I will show you a few use cases, concrete use cases, to illustrate how this can be implemented in a step-by-step manner by using smart sensors as well as AIoT no-code platform. So in the past, I would say the conventional production was monitored and improved through continuous improvement processes by monitoring OEE, overall equipment effectiveness. That is, I would say, in place in many industries since the 70s, and as at the peak, I would say, through the TPM continuous improvement in the 90s. But nowadays, there is, in addition to the availability, performance, and quality, there is a request, I would say, to improve as well the green side. So that means the emissions, the energy consumptions, and this is pushed, I would say, through the environmental regulations, who, of course, as well, the sustainability goals that are defined by the companies, of course, in order as well to reduce the operational costs, and as well pushed by the end consumers, like in the automotive industry. So that means it's also possible just to adapt a little bit the way that I would say the production was monitored through the OEE by introducing a fourth factor that is the specific energy consumption per production. And that's already in use and somehow was helped by digitalization and somehow appear at the same time as the Industry 4.0 wave. And regarding this Industry 4.0 technologies, they are really supporting the implementation and the real-time monitoring of this green OEE. So by having, I would say, an online data acquisition, as already mentioned by Sebastian before, you can monitor live what is the current situation, what is the current level of emissions, but as well the efficiency of the production. And once you have, I would say, the monitoring, you can then look on how to improve the situation. And there are, again, with this Industry 4.0 digital technologies, possibility to start counteractions for specific use cases to improve the situation. So I will now show you a few examples, starting from, I would say, big use cases, but going down smaller to, I would say, easier use cases that can be reachable for the small and medium industries. So starting for the, I would say, the emissions, if we look on the industrial sectors, and this is well-known studies available online, and that's also why I will speak about this sector. The iron and steel production is the main contributor to the gas emissions, so representing more than 7% of the total emissions. And in particular, I would say the conventional blast furnace and BOF route is the one generating the more emissions. That's why I started, I would say, the first use case by this type of industry. So in my previous experience working at Paul Wurth, I was leading the, I would say, digitalization team as well as the process optimization team. And we helped, I would say, iron and steel producers to optimize the blast furnace production. So this is a quite old, I would say, process. And in the last 100 years, I would say the specific energy consumption per ton of produced hot metal has been already divided by 3. So that means we are, of course, not able anymore to reach 30% of improvements by using digital solutions, but nevertheless, it's possible to reduce by 2-3% just by using digital solutions to optimize the process and then to reduce the energy consumption that is in the blast furnace, mainly coming from the carbon charged material and injected material. So the customer had the problem at the following problem. So that means a lot of emissions, pressure also from the governments to reduce these emissions, and also as well taxations related to these emissions. But not only that, I would say it's a quite complex process to maintain and also to ensure that all the operational shifts are operating in the same manner, in the same efficient manner. So this was, I would say, this is quite a big type of project where we acquire 8,000 variables every seconds from the plant, where we have then deployed a lot of process numerical models combined with AI models, and also capturing the knowledge and the best practices from the customers in terms of no-code rules that are automatically executed, giving a result of direct CO2 savings of about, of course, depending on the size of the furnace, to up to 100,000 tons of CO2 per year. So also inducing a lot of savings, I would say, in terms of cost, and generating quick return on invest. But these are big projects, I would say 2 years duration in average, requiring quite big teams working full time on this type of projects. Maybe going, I would say, to smaller other use cases, again in the steel industry. This is an example of a German steel maker where I would say the problem was the surface scratches on the produced billets due to a problem coming from the equipment itself. So that means the guiding rolls, the free guiding rolls, due to the arch conditions and due to difficulty of doing maintenance, were somehow from time to time stopping, blocking, and generating defects by scratching the products going on it. So the idea was to implement a quick solution to monitor first the situation, to learn where the problems were coming from, or what was the root cause, in order to be able to predict in advance the failure of the guiding rolls in order to trigger maintenance activities to avoid the blockage and the defects. So for that, we have implemented a quick solution using smart sensors, or I would say conventional high temperature optical sensors that are looking directly on painted mark on the free rolls, acquiring this high-speed data through an edge device, streaming live this data to the cloud in order to start building first some monitoring solutions, then learning the patterns and creating some anomaly detections when the mechanical problem starts to occur, in order to organize the maintenance really in time. And especially in these harsh conditions, this is always a problem over there. So by doing this, we have been able to deploy a solution, not only a monitoring, but really a solution that is avoiding this type of problem in 8 hours for the installation, and already the access to the first monitoring dashboards. And then a few weeks later, we deployed some models, I would say, predicting the failures and warning directly the maintenance team in order to make their maintenance activities. The good thing is that the customer was so happy that he saw the possibility to use the same approach and to extend these projects to other use cases. So that's on I would say on another machine, monitoring the failure of the shaft of the I would say of the coiler, just by detecting using high-speed signals with the same technology of acquiring and streaming the data, by measuring the distortion of the mechanical shaft. So again, very quick deployment and very quick solution to solve this specific problem. Other type of activities that are now really developed now by Industream with DSD automation as an integrator, we are providing our new platform that is a low-code platform to monitor the surface defects produced by a copper caster. This copper and silver caster, this is in fact, we have the solution for these two problems. So what we have put in place is that we have defined a digital twin. We have set up a digital twin that is, I would say, an extension of the engineering activities that we have done for this new plant. And then we have integrated, I would say, an AI vision system, embedding directly the platform to combine the image processing with deep learning and time series processing coming from the different sensors, in order to be able to first identify the surface defects and then associate the production parameters with these defects. But for that, we had to put in place as well an identification system. So once you detect by using machine learning approach and deep learning approach, you detect the anomalies, you of course inform the operators that there is a problem, and you use again machine learning to automatically, like fingerprinting, define an absolute ID of this plate, and then you can start looking for correlations between the defects and the process conditions. Another even easier use case, I would say, was for a recycling plant where I would say the customer had to produce reports and KPIs to the local authorities, tough authorities, in order to get the exploitation permit still valid. So we have been acquiring production data, generating KPIs and generating dashboards for this customer that is available automatically and sent to the authorities. What can IoT sensor bring in these use cases? First of all, it brings speeds by avoiding the conventional, I would say, cabling, wiring, modification of the automation system by enabling a direct acquisition and a quick visualization of the problem and then quick delivery of a counteraction. So for that, we develop our InduStream platform that covers this different step-by-step approach where we can adapt the content in a no-code manner for the different use cases. So it's quite unique in the fact that it can combine, as I've shown on one use case, I would say the possibility to acquire time series data and to combine them with video data. It was defined and designed in a way, especially using open source solutions, to be affordable for small use cases and for SMEs. So you see some example of this no-code design, and this, I would say, is quite complementary to the talk number 2 that was already given on the no-code platforms. But here we focus on the OT side, close to the machine in real time, with high frequencies, with the possibility to support the real-time decisions of the operators and even close the loop, I would say, with the automation system. In this platform, you can capture the knowledge of the operator and enrich this knowledge with AI by importing ONNX models or by directly importing Python code generated by the data scientist. The solution is scalable. That means you can deploy it locally on edge devices. You can deploy it in the cloud or on-premise at the customer. But we do not only provide, I would say, software, we also embed this platform into different kind of devices, including smart camera. You can then, as it was already shown in the first presentation, of course, enrich, in addition to all the available information from the automation system, you can add monitoring sensors to enrich the level of information, whether it could be vibration analysis and so on. But there is also, as we are talking about monitoring, also cheap solutions to do this. So as a key takeaways, I would like to say that this type of approach allows SMEs to unleash the data potential. Usually there is a lot of data available, maybe not in all SMEs, but and this data is not really used. A recommendation is to start small, but really with the potential to upscale. And as I have shown on the use case, to have the possibility to quickly deploy to other use cases. So the no-code approach has the same benefits as, I would say, on the IT side. It's bringing speed into the deployment of the use cases. So, but at least on the operational side, AI is bringing something, but not only AI. I would say you should really use and capture and trust the knowledge and the expertise that you have in-house. and make it available for everybody through this kind of platform. It brings transparency and helps as well to identify the bottlenecks and to have a better decisions on the future investment that, of course, will be necessary to, I would say, to reach further levels of decarbonization. I would say, as usual, the process remains a key. I would say having an optimized process will help, of course, as well to reduce the energy consumptions and the CO2 emissions. And the easiest way to achieve this, or I would say to reduce the carbon emissions, is to avoid the defects, because that's really consuming a lot of energy if you have to rework, I would say, the produced goods. So that's it from my side. I hope this will help.
Thank you, Fabrice. Thank you very much. So this is time for an open discussion, I would say, and managing all the questions that we could have received. By the way, there is no question, so our audience seems pretty shy today, but no worries. I think that you all guys would certainly have to would certainly want to comment the presentation of the others or add something. Just there is a question. Yeah. Thanks, Hiba. Dear Fabrice, thank you for the presentation. I work for the Flemish region, and I wonder if you have any project abroad, including Belgium, as there are so strong potential in Belgium. What I propose, Fabrice, is that you answer this very quickly, so we can jump into the core topic.
Yes.
So, about Belgium, yeah, I think.
Yeah, of course.
Yeah.
I would say I'm Belgian as well, so I my roots as well in Belgium. We started the company in Luxembourg, but we intend to grow quickly. I would say also to the bigger.
So you both will certainly connect on
Yes.
on LinkedIn or via email, or we'll
Yes.
do the matchmaking surely. Yeah, there was a question from me. So it was really interesting to see how at the different layer, I would say, technology is already there, and there is really some nice things, I would say, to work toward more sustainability. But on the regulatory side, because I know that the company are pretty shy for the moment in accomplishing this journey. But the regulation will come or is coming actually, the CSRD, Corporate Sustainability Reporting Directive. It aims at imposing extra financial reporting at the end, basically, roughly to all companies. And do you observe that this initiative will accelerate projects towards sustainability in manufacturing, or still not? Or is this something that you use already in your prospection? Yeah. What about CSRD, basically, in your business? What do we want to jump into this one?
Yeah. I mean, I can comment from my side, obviously less as the manufacturing sector and more on providing tools for them to demonstrate the primary data about these the reduction initiatives that they have. CSRD is big. It's mandatory for many now to be reporting on their science-based targets and how and what they're doing to reach them. The sorts of projects that we heard about from Fabrice and Sébastien. And the interesting thing for me here is not just the fact that you need to report this, but the CSRD is combined with something else called the SFDR, which is about the financial disclosures. And if you report these kinds of emissions and the sorts of really credible actions you're taking, you're actually opening yourself up to a wider investor base, because then there are wider investment funds who will be happy to invest further in you because you will align with what they call Article 8 or Article 9 funds, basically a firm who has demonstrable actions that reduce their emissions, and therefore you could be categorized as an ESG fund, basically, because you're doing these kinds of actions, and therefore you're doing not just your own business a favor, but you're actually crowding in more potential investors. So there are multiple reasons to do this, and I think those regulations are definitely an important part of the background here.
Thank you very much for this very interesting and on you guys, Sebastian and Fabrice. So as you are more, let's say, more on the shop floor, concretely, is this something, the regulation, that makes client come to you, or that you are using, or is this the project you are working on in the field of sustainability, or how are they triggered at the moment, basically?
Yeah, at least one of the use case that I shown was just to link to this kind of regulation, just to generate automatically reporting and dashboards for the authorities. Of course, this is one of the entry point, but not the only one. Usually, it's more coming, at least for my type of use cases, more coming from the internal optimization. I would say cost optimization team, and that's what usual. I would say continuous improvement, reducing. I would say the OPEX costs was always there and is still the biggest contributors to the request, but definitely regulations is increasing.
Thanks. Perfect. Sebastian, do you want to add something on?
No. Fabrice, you summarized also what we are facing when we meet the customers. It's first a question of direct costs, and then we think about the future, the regulation, and so on. But the most important driver is the cost, especially with the energy cost that raised a lot last year. So
yeah. So do you considering, sorry, that we are in a moment where basically we are bridging some very fundamental project based on the willingness to save energy, to reduce the costs, and something more global, I would say, something coming from the external side of the company, as you explained, Stephen, meaning how the company is positioned globally and how it could be financed by investment funds and things like that. And it seems that we are in an interesting moment where we are bridging these two approach, I would say. So, do you guys have something to add, or perhaps to ask to your peer, to speakers for the moment? At the moment,
I would just say that it's the proper timing, as you said. I would say the technology is mature and is easy to deploy. I would say there is also request from the authorities. There is push from the market, push from the customer. So we have all the conditions, and not only for the big ones. For the big producers, I think now it's affordable for all companies, and you just have to start, I would say.
Yeah. I think one of my comments would be, here we're talking about this Lux innovation. We have Luxembourg and Belgium and the immediate region here. There are the global value chains as well, and large firms based here procuring goods that are made in Asia, for example, where it's really difficult to incentivize them to reduce their emissions, maybe because their power grid is coal-fired. And therefore, how on earth do you incentivize and partner them to reduce their emissions, right? So that collectively, even if they want to, it's difficult to do. And so I envisage here as well, partnerships in order to co-invest in those kind of facilities and factories abroad. It would be great for Fabrice and Sebastien to be able to export these technologies as well to other countries. Easier said than done, right? Because of the human capital that might exist or might not exist over there, just as well as the technology. And so that's going to be a big part of the future, is internationalizing this approach, and also creative approaches to, policies, engineering, marketing, that actually enable the lower emissions sources for these firms that combine with these technologies to really make a big difference.
Yeah. Thanks for this word, and thanks for your interventions, gentlemen. So this webinar comes to an end now. We are running nearly out of time. Just a few seconds more to warn you about the initiatives that we are driving at the moment, or we will drive in the coming weeks. The DIH on tour is still on progress, I would say, and you, and particularly you, the manufacturer, you are more than welcome to jump in the bus and to discuss with your peers. That's really the philosophy of this tour, to make you known by each other. So please join us at dihontour.lu. Aside of that, for your information, there will be a cross event dedicated on AI, organized in 16th and 17th of October, that we will participate in. It will be in Karlsruhe. And the next DIH talk will take place on the 25th of October, and it will be about design thinking. And as you know, we are constantly chasing for valued speakers as the one that we get today. And whether you're an expert in the field or simply want to talk about how design thinking has helped you on one of your projects, be our guest and let's discuss together. So that's it, and we come to an end. So it remains for me to wish you all an excellent day and an excellent weekend too. And we hope to see even more of you in the next episode in October. See you. Bye.